now let's look at how high you would travel in projectile motion to get to your maximum height. Now that would be y sub h that we called earlier. This distance, the x distance, is r over 2. We're really not going to need that, not for this derivation. We have that this is v naught, and this is v naught x. That's v naught y as before. And we're going to be traveling in the upward direction to get to the highest point, so we're going to use one of the modified distance equations. Y is equal to v naught yt minus 1/2 gt squared. That's the modified equation of, it's the third linear equation, modified for free fall, negative g. It's negative g because as you go up, gravity is acting against you, so it's slowing you down, so it's a negative. And then v naught y, it's v naught y because it's the initial velocity in the y direction. The original equation was distance equals vit plus 1/2 at squared, and we modified it for that. We're going to make two substitutions. The first substitution is going to be for v naught y, because we showed earlier that sine theta is equal to v naught y over v naught. So v naught y is equal to v naught sine theta. And we just proved that the time that it takes to get to this point is equal to v naught sine theta divided by g. We're going to substitute these two equations into here. So we have y is equal to v naught y is v naught sine theta. And let's make these substitutions one at a time. So we'll just have time minus 1/2 gt squared. So we made this substitution. Now let's make the substitution for time. So y is going to be equal to v naught sine theta. We'll put brackets around that. Time is v naught sine theta divided by g minus 1/2 g. And then this is t squared, so it's v naught sine theta divided by g squared. It looks messy right now, but we're going to simplify this. V naught times v naught is v naught squared. Sine theta times sine theta is sine squared theta. So y is equal to v naught squared sine squared theta divided by g minus, this squared term is v naught squared sine squared theta. That is a g that goes up top. That g is squared, and this 2 is at the bottom, so we'll simplify that. We have g v naught squared sine squared theta divided by 2g squared. And in the next step, we're going to simplify this. We'll just keep this the same. We're going to cancel out a g term here because that's g squared and that's g, so we'll do that over here. Y is equal to v naught squared sine squared theta divided by g minus, we're going to go ahead and just get rid of this. And we're going to be left with the gravity in the denominator and no gravity in the numerator, minus v naught squared sine squared theta divided by 2g. We're going to find a common denominator. So if this is 2g, we're going to multiply 2 and 2 to here. So I'm just going to write that here since I have a marker board and it saves space. Now we can simplify this. Y is equal to 2 v naught squared sine squared theta minus v naught squared sine squared theta divided by 2g. And now if you'll notice, 2 v naught squared sine squared theta minus 1 v naught squared sine squared theta is just 1 v naught squared sine squared theta. So y is going to be equal to v naught squared sine squared theta divided by 2g. And this is the final form of the equation in order to solve for the maximum height that you would attain in the y direction if you know v naught, theta, and gravity.